Suppose f is a real function such that f prime x naught exists. Which of the following is the value of, limit as h approaches 0, f of x naught plus h minus f of x naught minus h divided by h? My instinct is telling me this is simply 2 f prime x naught. No, it's not. No, I'm sorry. Wait. Ooh. Wait, is that true? Yeah, it's yeah. Okay, we can show this. I mean, it's just, if we were dividing, look, easy way to see this is if in the denominator of this limit it's a 2h, then we just have kind of another way of representing the derivative. If you think of the derivative as a limit of slopes of secants, then rather than taking, what am I trying to say here? Let's typically the way we think of a derivative at a point like this is I take a limit of slopes of secants that all emanate from the point I'm considering, like that. But another way to do it is instead take the slopes, take the slopes like this. What's going on here? Why isn't this? Take the slopes on symmetric sides of the point like that. Oh my goodness, what? Like that. And the expression that's written here, if it were divided by 2h, here's x naught. This is x naught plus h. This is x naught minus h. And so f prime x naught is the limit as h approaches 0 of fx plus x naught plus h minus f of x naught minus h divided by 2h, which is exactly half of the thing that's written there. So the thing that's written there it needs to be divided by 2 to give the derivative. So the thing we actually have this is equal to 2 f prime x naught. There's another way that you could show this purely algebraically. Why don't I just run through that really quickly? So the other way to see this is to take the original expression, and now I'm going to add and subtract something in the numerator. And I've also split this up into 2 terms, so I've added and subtracted f of x naught itself. And both of these terms are equal to f prime x naught. So again, we get 2 f prime x naught. Yeah, not too much here. I guess understanding, sometimes it's easy to forget that the formula for the derivative, this limit as h approaches 0 of everything, basically comes from thinking of computing the slope of a tangent line that goes through this point, point in the plane where we're trying to compute the derivative. And if you understand that, then identifying that the expression we have here basically represents the same idea of approximating the slope of a tangent by a bunch of a sequence of the slopes of secants like this, where you're just taking the 2 points on either side of x naught. If I have much more to say about this one, I'll put it down in the description. Thanks for watching.